Well, hi, I'm Steve Morocco. You know me from the live forums and from tools I've been developing. And I've been experimenting with Claude Code to see how well we can use Claude Code for P2 development. I've been working also to try and create infrastructure so Claude Code can be more usable. So let's get started. What do you say? I'm a VS Code user and I've got it started here in my project. So let's get this set up. We are starting Claude Code just by typing in Claude. I'm using the default recommended, which is Sonnet, for this experiment. We'll see how it works. Typically, I use Opus, but I might be running against my Opus time limits today, so we're going to try with Sonnet. When you first get into an empty project or a project with code, say you've already been working with doing P2 development, but you want to start working with Claude in your project, go to the root of your project and just start Claude. And then I do an init in there because what it's going to do is study your code base and then create fine. And then this thing's random, I swear. Sometimes it'll create an empty or minimal Claude MD. Sometimes it won't do anything at all. Thank you for being relatively random. Anyway, I do an init. If there were code in here, you would study your code, you would describe the project to itself, and then record that in the Claude MD that you see right here. Since it hasn't done that, then I'll just go ahead and prepare it for your P2 use. Now, you know I already introduced in our AI forum a thread that I'm working on the P2 knowledge base. And so the knowledge base looks like this when you first enter it. What you really care about today is this one right here. So I'm Claude Quick Start, and basically I'm going to do all this heavy lifting by doing that. And then I'm going to make this go away. We don't need it anymore. Now what I'm going to do is hook Claude up, and it's real difficult. It's paste all that stuff here and let it work. I'll try and describe it. I'll describe what's happening as we're doing it. So first of all, I'm going to allow it always access to raw githubusercontent.com. So that's where the knowledge base is. And so I'm going to allow that. Anytime I allow anything, it records it right here in this setting. You don't care about that, but just so you know what it is. All right, and it's got instructions. It was told how to download this, and it's got instructions about how to set itself up. So we're going to be going through a number of steps here while it sets itself up. And you'll notice it's going to create a local cache. In this version, which you have access to, we're going to create a local cache. In future versions, I may have an add-on for Claude Code called an MCP that you can download and run, and it will do all this stuff in cache and save a cache that all of your projects can access, not just your current project. So not a big deal for right now. Maybe something easier in the future. So it's writing a script file. And I said, yeah, go ahead and do that. So we can begin to access content from the knowledge base. We're going to do this with a couple script helpers. So now it says, can I go out and get the instructions? And I say, yes, you can do that. And it's using a special boot sequence one, which is a smaller version of the fetcher. So now it's read that, and now it wants to create a larger version of the fetcher, and we're going to let it do this. What I've done is studied how Claude works with the knowledge base, and where needed, I created some helper scripts that it's downloading from the database to your machine. If you're on Windows, it'll download .ps1 files. If you're on Macs or Linux, it'll download .sh files. So what it's doing is these files, you can look at them. The source is right there in the P2KB cache. All they do is, given the path to the file, it'll access the knowledge base and download that file, and then make the contents immediately available to Claude. Claude doesn't even know really where these files are stored. It doesn't care. But they're all here locally in this cache. You can wipe out this cache anytime. You just got to reconnect to the database if you do. You can wipe out the files in it if you don't wipe out the scripts, and it'll just re-download the files as it needs. All right, so now it's going to take a little bit of time. It's just downloaded this AI instructions, and in there are content that it's supposed to put in Claude MD. This helps it remember how best to interact with the external P2 knowledge base. And it tells it how best to download, how to interact with the download helper and the fetch KB file scripts that we just installed. Since you see download helper kind of linked to OBEX, you'll notice that we created a little script to make it easier for you to get things from the OBEX. So here comes our mandatory start protocol, all the modifications. This is bash commands. This is fetch. Don't ask again for fetch commands, please. Hopefully now it won't prompt us anytime it wants to get something from the knowledge base. That'd be nice, because we just approved all the fetch commands. That's why we have a fetch script, because we can approve the use of that script, and then it will just use it from then on whenever it needs. And we're not going to be bothered by it as users of Claude. And by now, you probably have already approved this, because we just did. All right. So what I'd like you to do is we are going to be writing Spin2 code in this project. So I'd like you to read the Spin2 getting started, please, that you already have. This basically trains Claude in all the basics of Spin2. So it's got a good start. It doesn't have everything. It's enough that it can be productive out of the chute. And now, here's an interesting feature we added. Johnny Mac, has been creating code for us for quite a while. His documentation style is quite rich and very useful. So you can choose to use similar style documenting to him, or just do professional with basic styling, or you can choose VS Code. John, if you're looking at this, you can do your full styling using Claude Code, and it'll be as if you wrote it. Just saying. Okay, so we have this here because I'm a VS Code user, and because I want my documentation to be available in hover text and in signature type ahead help, I'm going to use the VS Code style. So what I'd like is number 3, the VS Code style, for all files that I create. For any files that I download, I will leave the files in their style. And so now it's going to pick up the standards, download that information, and understand it. So now when it does comments inside of Spin2 code, it's going to be commented in the style that you just selected. So for this whole project, this is the style that you should see. Fingers crossed this is working. Okay. So there's kind of reminding what VS Code style looks like. All right. Now I'd like you to add a couple notes to your Claude MD about files in this project. All files that I create or that we create together here all objects that we create will be named lowercase with underscores and will have an ISP prefix. All test files will be lowercase with underscores and will have a test prefix, test underscore. That's ISP underscore and test underscore. Also, all top level files that I'm going to create today we'll have the debug baud of 2 megabits, please. So it should put these kind of reminders in its Claude MD file so that whatever we do as we're here together on this video, it will remember all of this and do what we've just asked. So when you're starting a new project, you can define these things up front, tell it to put in its Claude MD, and it will remember this and be consistent. Again, the point of this video is show you techniques that we're using successfully. All right, so there's what it's done so far. And Claude MD is where it keeps project specifics. So now I've got some hardware set up to use. And you can imagine it's already figured out what we're trying to do here. And so now you can see my hardware. So I have some quadrature encoders hooked up to my P2. Can you check the OBEX and see if we have any objects for the quadrature encoders? So I have a push-to-talk button. I'm using audio transcription. And there'll be a link in the video description for what software I'm using. Feel free to use what you want to use. Mac has audio transcription built in, so does Windows. You can choose to use that. I just decided to use this. All right, and so there it's giving us a summary of it, found some encoders. Now, what I did in the OBEX, in the database, is pre-studied the OBEX and created an index of all P2 related files, and so it can just give us this. And now I'm going to say, okay, I'd like to use object number 2829, please. Can you make that available for me? And so I can either tell it, the name of the object or just tell it, and it should use, it's using the download helper script. And so Claude doesn't have to figure out how to download it. It just uses the helper script. And the helper script is going to create things right here under OBEX for us. And you can see it's unpacking it as it gets it. And it renamed the object zip file and things like this, so it has it. And it's not finished, but it just has. Okay, good. So now it's also told us and summarized what's here. That's why we use helper scripts. So this is just single step, super easy. Okay, what I'd like to do is I'd like that jm quadrature.spin2 copied up to our project folder, which is this folder, from its current location, please. If it depends on any objects, bring those objects as well. Okay, it's copying it up. That's a cp copy command on Linux. And it says we have it. Good, good, good. Object has no dependencies that understood. Excellent. Okay. Now let's do the next piece. We have to, based on my hardware that you see, we're going to need to be monitoring those inputs, but we're going to need to queue them off to a display of some sort. So what I need to do first is, okay, I'm going to need an encoder queue, or FIFO. Let's make it 64 deep. It's 64 words. When I push something, or when I enqueue something onto this queue, I'm going to be passing X and Y values. They're a byte each. When I dequeue something, I'm going to be getting X and Y from the queue. I'd like also a monitor or status method that returns how many entries there are, how many are full, and how many, and percentage occupied. We don't need locking because I'm going to have one producer, one consumer. And I'd like all objects that include this object to see the same data. Can you create an object like that for me? And since it's just a data and there's no hardware, it would not have a start method initial method, it would have an init initial method, please. So this is how I describe the object I want. And hopefully, since it knows some information about spin already, it should be able to create this object for me. So now we wait patiently while it thinks about it, and it's going to blast this file in pretty quickly. It's amazing. Now you could be using FlexSpin. You could be using Mac's tools for compiling, whatever you want to use. You might guess that I use pnut-ts. If you're on Windows, you can use pnut. And so we just created this queue. Okay? And if we look at it, it looks like this. It's got my ISP prefix because it remembered. All right. Single producer, there's the documentation. And it's not, yep, okay, it's documenting it. Pretty close. It's doing what we thought. Beautiful. There's the type of documentation that we would expect to see for VS Code. Okay. So it's remembered all of that. It looks reasonable in terms of structure, and it's put all the data in DAT like you might expect. It's doing a reasonable job so far. It's not a top-level object. So, okay, I'm happy with this. Now, where'd it go? Hello? Hello? Where's my... Hello? Where'd my keyboard go? There it is. That was weird. Okay. Instead of talking about this, because I want to spell it precisely, I typed it. You won't see me doing that very often. But let's kind of wet its whistle here. Wet Claude's whistle. That's our goal. Okay, as long as you have this fun little tool, let's go and see if your new code compiles. Now, if it were Opus and not Sonnet, Opus would have jumped on it and been compiling it and fixing it already before I even said anything. But look at that. First time out, complete without errors. That's pretty cool. Okay. Okay, now I'd like you to create a test program for this FIFO. We want to make sure that all of the methods work as intended. We want to make sure that if we hit limits, that we know that we hit limits, and if it's empty, and that it's all working as desired. I want you to use normal debug statements, no debug windows, just normal debug. And let's see. The other thing you should know is that you should probably reduce the queue size to something small to make it easier for testing. And you can do that with object overrides. Let's go ahead and generate this test file, please. Okay, so now I want a quick little test file. We're just going to put the new FIFO through its paces and make sure everything's working. Because I'm going to be using these tools a lot, and I expect some of you may as well, we also have some information about how to run these tools up at the P2 knowledge base. And so rather than introduce this third tool, this new one that I want to introduce to you by hand like I did with the compiler, and it compiled it, it's clean. That's looking pretty good. It's understanding code pretty well. Jumped it to 8. Good. Okay. And look, it's remembering the 2 megabit. Okay. You have information about auxiliary guides. There's one of those guides is for hardware testing. What I'd like you to do is access that guide, study it, and then I'd like you to remember the commands in that guide precisely. If you summarize it, you won't be driving the tools correctly. So remember the commands precisely and put what you find in there that you need to remember in Claude MD so you remember how to use these tools, please. So basically, I gave it enough to go out and find the guide, download it, don't summarize it, read the commands from it so we know how to run the tools, and then it should be able to do some debugging on its own. So the tool that I'm introducing is called pnut-term-ts. It's going to be available by the time we hit the live forum, the next live forum. It is characterized by being a Propeller serial term replacement, and it looks very similar initially. It automatically logs everything that it does with immediate flush of logs in a logs directory. And it also has support for the debug windows that we have, although I'm not going to be demonstrating those today. All right, there we are. So it remembered these commands, learned how to do them. Good. Okay, now what I'd like you to do is let's run your test for the FIFO and see what the output says. Is our FIFO working? So compile it for debug, download it to RAM, and let's watch the results. So what you should see is the new tool, although it's not completely finished yet. It will work so far. All right. Should fire up and begin doing testing. And if it can create the script correctly first. There we go. See, it looks a lot like Serial Terminal, and it fired up a term window. Okay, got some narratives wrong. Okay, it's waiting, it's checking. Okay, your test has completed. Let's shut down the test. And monitor's good. And tell me what you think of the test. How did it go? Okay, empty queue works, NQDQ basic operations work, full detection works, full. I like that term. The queue is full is what it means. Overflow protection works. Okay, status reporting works. And then what I noticed, good. The for trues actually corrects bin 2 behavior, good. Test code had a bug. I reused the entries variable as a counter in the test loops. Good. Okay. My fault in the test, not the FIFO. Bottom line, FIFO is solid and production ready. Okay, so let's think about what you just saw here. You saw Claude write the FIFO object. You saw it write the test object. You saw it compile the code. You saw it download it to the P2, run it, evaluate the logging, and has determined that everything is working well. Okay, that's fun. Let's keep going. Could have been a slightly better behaved, but I'm not going to fuss at this point. That was pretty darn good. Okay, now hi everyone. Where's that from? Okay, now you have the JM quadrature object, but my hardware has 2 quadrature encoders. So what I want you to create is an encoder monitor object that monitors both encoders. If it sees a change on either one, it's going to queue off both values as the next queue entry. So it's going to be writing to our encoder FIFO when it sees value changes. To describe our two encoders, the encoders I'm using, the X encoder will have values from 0 to 6. The Y encoder will have values from 0 to 7. Both encoders are detented. And then, okay, that should be good enough for now. And so can you create the encoder monitor for me? Oh, and let me give you some more things. But first, start with this. So after you get that done, my encoders are attached as follows. Pin 52 is the switch for the left encoder. Pin 50 is the left encoder B. And pin 48 is left encoder A. Then the right encoder is pin 8 is the switch, pin 10 is B, and pin 12 is A. Okay, so I gave it the additional information. It waited for me because I happened to mention I was going to give it more. That was cute. All right. And there are the details that I told it. So now it's going to create this thing. And we'll go out and look at that. So now we have a new encoder monitor object with ISP. All right. Okay. So let's see what we did. There's our pins. Okay. Our setup. Two encoders. The FIFO. Has it in var. Doesn't matter in this case. There's only going to be one instance. There's our start and stop. FIFO init. Encoder starts. Detented is true. All right. It's using cogspin to start the monitor. There's our stop. There's a get X, get Y. I'm not sure why we need those. Pressed is that. Okay. Monitor. Here's the task. Repeat. Get the current ones. If current is different from last, then enqueue and set last. That looks pretty good. Okay, now. Okay, we shouldn't need a wait. You can check the encoders as fast as you like, so you can remove the delay. Since this encoder is going to be responsible for all of the monitoring and sending of data to other objects, we don't need get methods. So you could reduce that. Remove those methods. That's how I edit my speaking. Okay. There you go. It's removing the gets. Sweet. Okay, said we don't need them. Said we don't need the delay, so it fixed that. Very cool. It's compiling it. Is everything compiling? That looks pretty good. Okay. All right, let's move on to the top level of our object. And for right now, all it's going to do is test the encoders. So the top level should be responsible for starting our encoder monitor, and it should be responsible for reading all entries from the queue as they come. And let's just use debug statements to tell us what values come through the queue. And this way we can exercise our encoders just by twisting buttons, and we should see debug output that tells us what's happening. Let's see, this is our It is our Etch and LED top level file. Twisting buttons, twisting the knobs. You know what I mean. It'll get it right, don't worry. Okay, another thing for the Claude MD is that our top level files don't have to have the ISP prefix. And so let's just call this Etch-a-LEDs instead of ISP Etch-LEDs. All right, so there we are. It moved up to the top of the file list. And let's see what it did to create it. It's still modifying the file a little bit. All right, it's compiling it to see how it compiles. Looks like it compiled clean. It shows a clock freet, has a debug baud, has our monitor and our FIFO. Yeah, it's doing that. Okay. To clarify, when I say debug baud, that does not mean, and you should check all your files for this, that does not mean we set up a debug term window with baud. All that means is that we create the constant in the file, and the constant, the compiler will see that constant and do the right thing. So let's remove all debug term statements that you have in test files in this main file. In this main file, please. Voice transcription. It's a debug baud. Cool. Yeah, my pronunciation could be better. Enunciation is not my forte. Okay, so there it took it out of there, and there it took it out of the test encoder. Good. That's why that extra window showed up. It was doing a term window. Okay, so now. Good. And it's remembering it in Claude MD, so it won't do that in the future. Very cool. So we shouldn't see that behavior anymore. Alrighty then. Okay, now I'd like you to compile this top-level file with debug. I'd like you to download it, and then I'd like you to monitor the log for, let's say, 60 seconds, and I'll play with the encoders, and we'll see what kind of output we have, and then go ahead and shut down the test facility after that. And let's see, monitor start, monitor encoders, all right. Then if FIFO is empty, not empty, we DQ, we get XY, we document it, and we get some status. So it's going to be a little bit busy. Oh, and one more thing before we do this test. Go ahead and remove the wait for each entry in the queue. Let's just process them as fast as they arrive, please. Okay, so let's watch our test and see how things go. There, it's removing the wait. Thank you. Compile with debug. Thank you. Download and run. It's in RAM. It's debugging. I play with the right encoder. I play with the left encoder. Looks like they're both working and they're fast. And now what we see is we have a problem that both are stuck at 0. All right. So let's watch it. Oh, well, I didn't okay that. That's error after. Okay, so we just saw the encoders stuck at 0. This is actually an error with Johnny Mac's object. Okay. The test has completed. Go ahead and shut down our test framework, the monitor script and the downloader. And I've got an observation for you. Occasionally it'll be hung in one of those things, and so you just have to interrupt it and then give it your information, and then it'll figure out, oh, okay. And it'll shut everything down. Okay, excellent. And one of them wasn't running, so nothing happened. Okay, what we seem to have a problem with is that the encoders, when they reach 0, I suspect it's when they reach either limit, when they reach 0, they're hung at 0. Can you study the JM encoder code and see if you can find an issue with it, please? Now, Claude code is pretty good at understanding code and what it means. And so hopefully it'll be able to understand what's happening here. And help us out. So now I'm going to get rid of this and I'm going to go full screen because we're going to be wanting to see more of what it's going to tell us. We're making good progress so far during this demo. You hear that bing? That's because a new file arrived. Okay, look. Well, this is interesting. Okay, beautiful. Good find. Okay, let's go ahead and fix that encoder. Adjust it as you see we need to, and then we'll test again, please. And you see it's doing the set low limit. It thinks we shouldn't be doing that. So it's reading the file. It's going to do some edits against the JM quadrature file. It shows a different way of editing it this time, so we don't see the diffs. Thank you. I wanted to see the diffs. You short-sheeted us. Okay, here we are running. All right, we're playing with the left one. We are at 0. We're going away from 0. 6, 7, 8, 3, 2, 2, 1, 0. Let's go back up. And it's working. It's going back up. We play with the right one. Goes to 7. And it comes down from 1, 0. Goes back up. Good. Okay, both encoders are working. All right. Okay, that fix worked. Both encoders are working now. So now what I'd like you to do is let's create a folder, and I would like you to identify which object we used, object number, the data was uploaded, and things like this from the OBEX. And let's create an email to Johnny Mac. Create a folder with the email, and I'd like you to save off a copy of the fixed encoder, the JM quadrature file also. When we do this, do not change the file at all other than our edits. Just copy the fixed file into the folder and create an email for me. You can use Markdown for the email, That'll be fine. I'd like you to describe which object it was we used, what version it is, and the date it was uploaded to the OBEX. And then I'd like you to describe the nature of the problem and what we found, what the symptoms were. Then I'd like you to describe what your fixes were and why. And then put that markdown email and the copy of the working file in this folder, please. And we'll just save that so we can send that to Jon later. Sorry, Jon, it's spelling out the full name. It's not my fault, it's voice transcription. I would know better. So I just want you to see, we're trying to be a good citizen as a user of the OBEX. We found an issue. And here we have the correspondence with Johnny Mac that it created. All right. Doesn't have anything in it yet. It will shortly. There's our fixed quadrature. This is Sonnet. Sonnet loves to rename files. Absolutely. Watch this behavior. Do not let it do this. Nobody would make any sense of that. Now it's thinking about the letter, I'm hoping. There we go. Wrote 122 lines. Really big email. Let's look at this, but I want to look at it in a way that we can read it, please. So just give me a preview. And so here's what it wrote to Jon. Object ID, author, uploaded, blah, last updated, blah, OBEX page, okay, file. Okay, now one more thing. Thank you for doing all of this, but I would like you to make sure that the name we have in the correspondence folder, the file name for the spin2 code, is exactly the name of the original file. Do not rename it, please. So occasionally you have to guide it. Anyway, carrying on. Problem description. Symptoms. All right. They would hang or get stuck in their configuration. All right. Observe behavior. Root cause analysis. Why is this a bug? The problem. The fix. All right. Now imagine you develop this object. Would this be sufficient to tell you if you liked the fix or not, and whether you would apply it and re-upload your object? I would hope so. All right. And there's the email. So here I am using Claude to help me be a good OBEX citizen and generating a defect report mail. All right. Now let's carry on. Okay, now we have to have a display for our Etch-a-Sketch. And I gave you a source file for reference. I got this source file from the Quickbytes. One of our members put an example of how to drive the add-on LED board, the charlieplexing add-on LED board, up in Quickbytes. So I downloaded that file, and I want you to study it, please. That starts with CJMJ and ends with spin2. Study that file and tell me what it does. All right, now this file, the way it's written, tests the LEDs, so we know that they're working, but it's not sufficient for what we want to do. So we need to adapt it. But we have Claude. Claude is, in essence, our exoskeleton. I can do all this by hand. I can read it, study it by hand, but Claude amplifies my ability. I tell it what I want to do, and it does the work at a much faster rate than I can. And it's pretty good at it, as you've seen so far. Very few compiler errors, fixes things we ask it. It knows about code patterns, and so it's doing things as we want them to. And I've been teaching it code patterns. How did it learn code patterns, you might ask? Hey, Steve, how did it learn code patterns? It learned code patterns by me having Claude download all the OBEX P2 stuff, open up all the files, study all the files, create idioms, and create patterns for different things it saw. And then for other, including the larger projects out there. And so it just studied everything. It studied our flash driver. It studied our BLDC motor control. It studied the matrix driver. It studied, you name it, it studied it. And then it captured patterns that were used frequently. And that's what the P2 knowledge base has now for building code. I suspect that's part of why this is so successful so far. Okay, so here we are, how the code works. Charlieplexing technique has a base pin. All right, main loop logic. All right, floats all pins, cycles through the LEDs, waits for on duration, floats them again, blah, blah, blah. It's telling us how it all works. Okay. Okay, this is great. Now, continuing in spin 2, we want to create our own driver for this LED that uses all the techniques in this file that you just read, but it's going to run in its own cog, and it's going to keep the LEDs lit, if you will. It's going to receive set given pixel at row column on and set given pixel at row column off. You might as well add line drawing and circle drawing to the driver so we can do a quick test. And so let's do an LED driver object patterned after the code you just read. Okay, so now I should have the ability to keep the LEDs lit. Charlieplexing requires constant scanning. And so now we'll have the cog doing the scanning. So now we have one cog monitoring our encoders. We have another cog doing the scanning LEDs. And then we have the main cog running the overall system. So it's thinking about this, and then it's going to blast the code in. I'm expecting another ISP file here anytime soon. Oh, meanwhile, one of the extensions I use, see how cluttering this is? Add to hidden items. Don't show me bin files, please. They just clutter my display. Let's see, don't show me this file, because that's something from my tools that I haven't stopped creating yet. This is something from my tools that I haven't stopped creating yet. Let's just get it out of the display. If you see it, don't show it to me. I don't need to see object files. All right. So I use add to hidden items extension. And so you can see which ones I've hidden, and you can unhide them just by unselecting them. So you can see them come back. But I have that here just so it keeps this display clean. I can hide these folders too, if I want to. Okay, so here we have, it named the file, and we have a new file here. This is what it created. Run continuously to maintain LED display, provides pixel manipulation, stop, start, clear, draw a line, set pixels, pin fields. There's our LUT tables. Interesting. Wonder if it's going to work. We don't know. Anytime it's going to edit a file, it has to read it first, then it does edits. It compiled it, found some things it wanted to fix. All right, good. Here are the details. Good. All right, but now we have to hook it up. Okay, so let's do this. Let's take our top level file, Etch LEDs, and let's start the LED driver. And then I'd like you, for 20 seconds, run test patterns against the LED board. After 20 seconds, I want you to then set the dots. Anything that we read from the queue that says turn on an LED, do that at the X and Y positions that are coming in on the FIFO. So become the real device, become an Etch-a-Sketch after the 20 seconds. How does this sound? Okay, so now we're going to move towards, do we have a real Etch-a-Sketch? And we'll get this going. And hopefully It figured out how to drive the LEDs. Sometimes it doesn't get this right. We're going fingers crossed here, okay? I had one case where it actually started to go into PASM because it thought that an interpreted spin isn't fast enough to drive the LEDs. I had to convince it otherwise. That was entertaining. Okay, we're building with debug. There's our test pattern sequence. It's going to fill the display. Cool. It's going to clear the display, do corner pixels, horizontal lines, vertical lines, diagonal lines. Cool. Circles, box outline. Very cool. After 20 seconds, it clears and goes into Etch-a-Sketch mode. I'm liking this. All right. So, okay, let's do it. Compile for debug. Let's download it and see what happens. Okay. If our conversation gets too long, by the way, with Claude, it can start getting random behaviors. So if you start seeing it do weird things, okay, our LEDs are working. Look at this. There's our four corners. There's our bars, horizontal bars, diagonal lines. This is pretty cool. It studied the code, it wrote the code, adapted it to running in its cog, and now turn encoders to draw. Okay, here we are. So that's down. This is right. This is up. Whoa, it's fast. Okay. Now, guess what we can't do? We're stuck drawing. Okay. Huh. Let's finish up this project now the way we need to. Oh, yeah. Okay, fine. It's compacting. We have to wait till that. Continue. We have to wait till that finishes. We can't talk to it. It's busy. This is the one thing I don't like about Claude or any AI. You'll always have this. Don't worry. It's just going to go away and make you wait for a long period of time. Watch the clock here. 18 seconds, 19. This is going to be some awful number, a little over a minute. I don't recall, but watch this. When it's done, this number will stop and the whole screen will clear. And then it'll come back with what files was it modifying. So watch for this number. We'll see how long this is. It's always too long because inevitably I'm in the middle of thinking something, want to tell it, I'm anxious, and then this happens. So this is life with AIs. You've seen it before yourself if you've already done this. Okay, so we have one more feature to add. What do you think it is? All right. Then we'll call this project wrapped, and this has been fun. So what have we seen? We've been seeing full round-trip coding. We've been seeing it's doing compiling. It's doing its own fixes. When it sees it doesn't compile, it's using the pnut-term-ts. So it's just doing the one-line compiles. The first error it fails, it sees it, it fixes it, compiles it again. So it's working that way fine. If we were using FlexSpin, it would be reporting multiple errors, and it would just sit and work through all the errors. That should work just fine. We're working in Spin 2. I've been teaching it Spin 2. Claude Code works with many languages, so those of you using FlexSpin with multiple languages, you can have it work in your other languages. That should work just fine. All right. Our board is still sitting there with the LEDs on. We have to figure out what to do about that. Okay. Sure. Tell that. I'm going to short circuit what it was going to do there. Okay, things are working really well. All the code is working. We just need to add one final feature. So go ahead and shut down your monitor and your downloader, and then we'll add the final feature. The red stuff coming out of debug terminal, That's still diagnostics that I haven't turned off yet. I will have that all turned off when we ship this. Okay, so you might think we need one more feature. What I'd like you to do is add to our encoder monitor the monitoring of the buttons. And if you ever see both buttons pressed at the same time, then I'd like you to enqueue the value 255, 255. And that will be our clear screen feature. Then in our main application, I'd like to, when you see the clear screen dequeue, I'd like you to clear the screen on the LEDs. Let's go ahead and implement this feature and then run the test again, please. Oh, and you can comment out the LED. No, just leave it in. I was going to tell it to take out the 20-second monitor, but we can afford to see that again, can't we? You won't mind, will you? It's too much fun. And maybe we should put the drawing was so fast. Maybe we should put some of those timeouts back in there again. I took them out, but it's darned fast. So adjust to your heart's content. You can recreate this in a heartbeat now that you've seen how this works. Okay, you see the edits and the changes it's making to the file. It's changed to a clear screen debug. How cute is that when it sees the 255s? Otherwise, it just draws. Do I want to proceed? I should probably let it do that. I was reading the code. I was busy reading. Leave me alone. Okay, so here we are with the LEDs running the test pattern. Reasonably fast. It's got lots of timeouts in there, I'm sure. I don't know. Okay. And now we're about to say, turn encoders to draw. All right, so now I'm drawing, maybe. There we are. Where am I? Why is nothing moving? What's happening? It stopped working. Oh, there we go. All right. Why is it giving me problems? There's X and Y. Why is Y giving me problems? X is working. Y is not working for some reason. Oh, what's it saying? Do you want to proceed? Don't ask again for awk commands. What does it want? Oh, that shouldn't have anything to do with me, but it does seem to be. Okay, so X is working. I can go back there. Why did Y quit working? All right. All right. Okay, shut down the downloader and the monitor. It seems we developed a problem with the Y axis. Can you see any reason why the Y axis might not be working? Is it in our encoder monitor? Is it in the top level? See if you can find out why. Oh, hold on. It didn't take the second one. Sometimes it'll actually let you see its thinking. Then you do a Control O or something, it can expand its thinking. But it'll tell you that, right? See the Control O right here? Doesn't have it right here. Now you can. The net result is I've never had it get to a situation. I've been working on lots of different code now. I've been working on TypeScript code with Claude. I've been working on Go, the language Go code with Claude. I've been working Oh, oh, oh. It thinks it found a cause. There was a blocking delay on the button monitor. Ah, that was a debounce delay. So it probably needs a different way to monitor that. But we'll let it do what it thinks it should do. Let's try it again. See if that was the problem. Cool. If that were a problem, then we can just have it do debounce a different way. Yeah, it found an old version running. I'm just going to check force quit. Nothing's running. We're cool. Okay. Yeah, don't ask again. I don't like you doing pkill, but it's needed right now. Pkill is a process kill, and it's very unfriendly if you want to shut down logs in the application before you die. And so I ask it not to use that normally. Okay, here's a download RAM. This should be there's our demo. Okay. Fingers crossed we have X and Y this time. I don't know why X would have been working. I don't think that was the solution, but if it is, very cool. Turn encoders to draw. Well, there's Y working. There's X working. That, well, I guess, was the solution. So we will stop there, and we'll call it a day. Okay. Okay. All right, the code is working again. That appears to be a reasonable fix. Let's go ahead and shut down your test programs and the monitor. And you see these blue down here. That says you've got things running in the background. All right. All right, just for fun, can you summarize the work that we did for this project and the files that we produced, please? And generate a markdown document telling us all about this. Okay, so as a wrap-up, I'm going to let Claude describe what we did. But meanwhile, what I want you to appreciate is in this amount of time, we took hardware that we had set up and tested with the external board, LED board, and we have 2 quad encoders. We downloaded the code, made code that runs in separate cogs to monitor the encoders, made code that runs the LEDs in a separate cog, and we have the main. We created a data structure, FIFO, that was receiving the encoder inputs and queuing them off, and the main app was reading the FIFO and then sending it to the cog that was managing the LED. And we did all of that by voice with full download round trip work with just tools that we'll all have available. So I just wanted to show you how easy this was and how it's working today. And remember, this is a large language model that was not trained on Spin or the P2. Nearly all of the documented concepts are available in the P2 knowledge base to the Claude. So if you ask questions about what hardware is available, if you have an Edge module and you have the one of the boards assigned to pins, and you can actually tell it that you have such and such a board on pin group such and such, and it should be able to write code for it. Now, I have 2 serial ports, and I want smart pin behavior for serial ports. You can ask it to actually write that code. You can download Johnny Mac's driver, and that will work for you. Or you can just say, I've got my serial pins here. I want to run at 15200, and I want you to create the smart pin driving code to do it. And I'm writing in Spin 2 or I'm writing in PASM 2, and it should be able to do it for you and have it running. There's this amount of information in the P2 knowledge base where it should be able to do this for you. It should understand all the smart pin modes at this point, And it has the examples that have been created by Titus, John Titus, is that his name? And by anything Chip has done in the Silicon Dock and things like this. It's got all that example code that it studied and learned the concepts from. And so you should be able to do these kind of things. And so I would like you to let me know when you have successes with all of this stuff. Just before we leave, let's look what it says. Create the project summary. Complete hardware configurations. All right. 3-cog software architecture, all 10 files. Key features, real-time drawing, clear screen, test patterns, graphics primitives. You saw how it did testing and how quick it was at creating tests. So imagine that you have unit tests for your hardware or data structures, or you want to test your displays, or you can create tests very quickly. You saw how rapidly we did that today. I asked it to create the FIFO. It did a rich job of creating a FIFO, even with extra methods we didn't need. I asked it to generate a test for the FIFO for full range testing, and it did. And it worked. This is pretty powerful, I think. So this is going to be fun for grabbing hardware off the shelf, hooking it up to your P2, describing into Claude how it's hooked up, and then writing code for it and just experimenting. This works, and it's fun. And I can develop an experiment much faster than I could before because I'm using this technique, using Claude code to write P2 code. That's what I want you to understand from this video. Okay, so here we are, architecture. Let's look at the summary. Let's close down. Let's minimize this for the moment. Let's go look at the summary in a useful form. Preview. All right. So here's what it said. Project overview. Etch-a-Sketch, quadrature encoders, charlieplexed LED matrix, clock frequency, debug baud rate, cogs used. So you write a project, you develop all the hardware, you get all your stuff code. Documenting it is a breeze. I just asked it to summarize what we built and look at what it's telling us. How long would it have taken you to write this kind of documentation about it? Writing user manuals? Simple for your application. I want you to understand that as well. Downloading from the OBEX? Simple. Then one of the next features coming up, downloading from Quickbytes. Okay. Understanding which Quickbytes are available, giving you links to the videos for Quickbytes. It can't show you the video, but it can give you a link and you can click on it. So you'll have that kind of capability coming up. So here we are, describing the application files, test files. Which objects did we get? Thank you, John, for that object. You'll hear about I'll send you the correspondence, John, just for fun. You probably already know about this, but I'll send it to you. Reference files. All right. Then what did we put in? Hardware. Key features, real-time drawing, clear screen function, comprehensive test patterns, graphics primitives, lock-free FIFO, critical bug discovery and fix. What did we find? Second bug fix, polling issue. Okay. Development process. So yeah, all I did was say summarize what we did, and it kind of went crazy. So there we are. This is our project stat. All right. And we wrote that, and it wrote it in such a way that I didn't have to inform it any kind of sophisticated detail about how to do this for the P2. It has patterns. It knows patterns. And so if it doesn't know, because you told it to automatically access stuff, the knowledge base is a download on demand system with over 1,000 different files that it can download and study. Each of the PASM instructions, each of the methods, each of the collection of constants for spin 2, the constants that are available, you name it, right? All the smart pin modes, detailed information about each of the smart pin modes and how to configure it. 1,000 different files. This is all available now. Download on demand. And that's the facility I just showed you how to set up. Well, there we are. This is our demo. Let me shut this down. And basically the way you get out of Claude Code is just to quit. I'm going to be polite. Hold on. Overly polite. Thank you for your help. This was fun developing this project together. It's my paired coder. Claude Code is a paired coder. It talks to me. It discusses things with me. It tells me about the code it shaped, that it sees. I can ask it, what are the different architectures using P2 facilities? How would you decompose the problem that we're trying to solve and put it in? I just told it how this time. You could actually ask it, and it should be pretty reasonable. It's also pretty cheery. All right. How do you exit Claude Code? Quit. All right. See ya. All right. Shut down the terminal. Shut down this. Oh, I guess we left this running. Shut down pnut-term. All right. So there you are. What you saw was Claude Code understanding P2 out of the box. After I told it that we were going to be writing in Spin 2, I had it read the getting started for Spin 2. It knew enough to write nearly perfect code immediately. We saw a couple times where it tried to do parentheses around ifs and things like this where other languages were interfering, but it compiled it, saw it wasn't a good idea, and took it back on again automatically. We saw it write tests. We saw it download from the OBEX pretty cleanly. Pick files out of what it downloaded. We saw it study existing code, tell us about how that worked, and then implement using those techniques our own objects. We saw it discovering defects and finding solutions for the defects. This is quite a rich set of things it can do, and this is ready for you to use now. By the time we have the live forum, I'll have a release available and the announcement will have been made for pnut-term-ts. Not all of the debug windows are in place, but many of them are. So you should be able to do a lot of the interfaces. Now, I want you to think future. Claude Code, Johnny Mac, I'm talking to you, people like yourself, and people who like your debugging techniques as I do. You're drawing these bitmaps and using the layer and crop commands. Imagine that you can verbally describe the image that you want. Claude Code creates the BMP files. You then describe the interaction that you want and which regions show when. Claude Code builds the plot window, loads the plot window with the things that you want, and can create that entire display with you, and you don't need external graphics tools. This is totally feasible. So just how much fun can you have? How quick can you come up with a 7-channel equalizer display using the crop and layer techniques? Just off the top of my head ideas, right? How about visualizing the state of your queue? How empty or full is it as a debugging tool? So you throw up a plot window that visualizes it and shows you how full it is as we're running this little LED Etch-a-Sketch here. You can do that. So I just want you to think about these things. Think about the fun you can have doing the voice work. And think about how you can do more advanced work. You have a P2 project that you've been working on for a while. You point Claude Code at your P2 project. You ask it about issues with your code. You ask it for help in refactoring your code. You ask it for doing extensions, add commands like this that do this, and it can add that to your code. It can do regression testing for you. This is pretty amazing. Now, it's not full understanding of what it does. It's an exoskeleton. I've said this before, just to wrap up. It's an exoskeleton. You take off the exoskeleton, it can't do anything by itself. Without you driving, or not in any significant ways independently. That'll happen soon, but for right now, no. I don't want to see that personally. But anyway, it can amplify what you do, how you think, and accelerate your workflow for doing and building hardware with the P2 and developing the code for the hardware and get it running quickly. I guess I should stop here. I could keep talking all night. Anyway, I'll say a final time. Thank you for watching. And I hope this was informative. And I hope you're going to be enjoying the tools that I've been working on. And keep enjoying them. And just have fun. Let's have fun with our P2s. What do you say? Not that we aren't already, but in whole new ways now. Bye for now.